Okay, so this is the M3 paper from June 2017 IAL. Okay, so we'll discuss question number 5 over here related to chapter 1. Okay, so a particle P of mass 0.4 kilogram moves on the positive x-axis under the action of a single force. Okay, so in this question, there is a force component that they are talking about. Okay, the force is directed towards the origin. So when they say it's towards the origin, you do need to realize you need to put a minus mark and has magnitude k over x square, which means what? The force is equal to k over x square, but because the force is directed towards the origin, the force is equal to minus k over x square. Are you with me? So when they say it's directed towards the origin, it is you have to make sure you mention the negative sign. Where OP is x meters, so O is the origin, P is where the particle is, OP is x meters, K is a constant. Initially, P is moving away from O. So initially the particle is moving away from O. At x equals 2, the speed of the particle is 5. Okay, so these are the boundary conditions. What are they? At x equals 2, the speed of the particle is 5, and at x equals 5, the speed of the particle is 2. Okay, so they are giving you two boundary conditions. At x equals 2, speed is 5. At x equals 5, speed is 2. Find the value of k, and you can see they've given you how many marks? It's a 8-mark question. Okay. So here, there is a, you can see they're talking about the force here. So when we talk with force, we know always we go with force by using Newton's second law, which is F equals ma. So we will go with F equals ma. We know F is equal to ma. So instead of the force here, we will go ma equals minus k over x square. Are you with me? And now the thing is, you have again the acceleration here. Okay, mass is 0.4 kilograms. We know that. So you can see here again, your acceleration is what? A function of time or displacement here. The acceleration here is a function of time or displacement. Acceleration here is a function of displacement, and thereby you must use acceleration as what? Whenever acceleration is a function of displacement, we need to use acceleration of as v dv by dx or d by dx of half v square. So I will use, instead of acceleration, v dv by dx, because the acceleration is a function of displacement, equals to minus k over x square. So let's simplify. So you know what we do in over here, right? 0.4 into v dv. So I'll move the dx to the other side. Dx, so it's minus k over x square into dx. Okay, minus k over x square into dx. Okay, so you can see I have successfully separated the variables. So over here I have the dv, v with dv, and the x term is on the side with dx. And now what do we do? Both sides we will integrate. So I will integrate both the sides. So what do we get here when we integrate? 0.4. When you integrate v with respect to v, 0.4 is the constant, so let it be there. When you integrate v with respect to v, we get v square over 2 equals over here minus k over x square. How do we integrate? To integrate, I think the first thing is, are we going to use ln rules here? Because it's a x square, not a 1 over x. It's a x square. So to integrate, make sure you bring x to the numerator, because there is a x power here. So it's minus k times x to the power minus 2. I didn't integrate this side yet because I brought the x square up. Let's integrate it now in this step, v square over 2. So minus k is a constant. Let it be there. X to the power minus 2, when you integrate, what happens? You add 1 to the power. So x to the power minus 1 divide by minus 1. Isn't it? You add 1 to the power and divide. And then don't forget the plus c at the end of the complete integration. You have to put a plus c. So 0.4 over 2 is 0.2 v square, isn't it? Minus divide by minus is a plus k into x to the power minus 1 plus c. Are you with me? So I get this equation. You can see this equation. Now they ask us to find the value of k here, right? Okay, so in part A, 8 marks, you're supposed to get the k value. How do we get the k value? So you can see in this equation relating v and x, there are two unknown, k and the constant c, the integration constant c. So to find this k and c, I think you can see they have given you two pairs of boundary conditions. When x is 2, v is 5. When x is 5, v is 2. So we will input those values, and I think we will be able to create a pair of simultaneous equations. Let me rearrange this first of all. 0.2 v square kx to the power minus 1 is actually k over x, right? Shall I write as k over x? Okay. So we come to this point. Now shall we substitute? What's the substitution we go with? When x equals to v is 5. Let's go with that. When x equals to v is 5. Let's substitute. So what do I get here? 0.2 into v square is 5 square equals k over x is 2 plus c. Are you with me? 0.2 into 5 square is how much? 0.2 into 5 square is 0.2 into 5 square is 5. 5 equals k over 2 plus c. So this is like your first equation. Okay. So the other equation, how do we make it? The other equation is from the other boundary. When x is 5, v is 2. When x is 5, v is 2. Input the other boundary. What do we get here? 0.2 into v square is 2 square. K over x is 5 plus c. How much is 0.2 into 2 square? 4 over 5 equals k over 5 plus c. So this is your second equation. Now what do you have to do? Solve these two equations and get the value of k. They ask you to find the value of k. Okay? Get the value of k. It's like a pair of simultaneous equations. Okay, so then we'll solve these two equations and actually get the c value. I think it's easier to solve it by subtracting the two equations. The c value will cancel out, right? Shall I subtract the two equations? 5 minus 4 over 5. Okay, when I subtract, I can see when I subtract the four equations, the c cancels out. K over 2 plus c, if I subtract with k over 5 plus c. Now, the thing is, this is a pair of so equations that you have to solve simultaneously. You can do this in any way you like, okay? So this is just, I'm doing the subtraction method. You could do this in any creative way as long as you get the answer correctly, it's okay. I'm going for the subtracting method. 5 minus 4 over 5 is 25 minus 4, that's 21 over 5 equals k over 2 plus c minus k over 5 minus c when you open. So the c cancels out. K over 2 minus k over 5, right? How much is it? So I end up getting 21 over 5. So 5k minus 2k, that's 3k over 10, right? So 21 into 10 over 5 into 3 equals k. So I end up getting how much is it? I get k is 7 times to 14. K is 14, right? When you input everything, k is 14. So this is the answer for part A. Because in part A, they ask you to find the value of k. That's it. So you stop it at this point. This is the k value. Okay, so then moving on to the part B. The particle first comes to instantaneous rest at the point A. Find the value of x. Okay. So again, what do you have to do here? So I think we already got the equation V with respect to x, right? We already have the equation. Particle comes to instantaneous rest means what? Simply you input V as 0. Simply input V as 0. Let's get the answer part B. But I think for part B, I will, to get the velocity equation completely, I will need to find the c value as well. Can you see the velocity equation has k and c? So let's input the c value. I will need to find the c value. Shall we find the c value? Substitute k is 14. So I will have to continue this calculation. Substitute k is 14 and get the c value. 5 equals k over 2 plus c. I'll use it to that. 5 equals k over 2 plus c. So 5 equals 14 over 2 plus c. 14 divided by 2 is 7. So 5 minus 7 equals c, which gives me c is minus 2. Is that okay? So now let's input the c value into the main equation and get the velocity equation first. So we'll input the c value into this main equation. What is the main equation? 0.2 v square equal k over x plus c. K is 14, c is minus 2. Repeat the equation to me again. What is it? 0.2 v square equals k over x plus c. Let's input the values. This is the main equation. 0.2 v square, k is 14 over x plus c. C is minus 2. Okay, c is minus 2. Okay, so then in this equation, actually, you don't have to go to the, do we really need to go to the extent of making v the subject? Do they ask us at any point to give the equation v relating x? No, they have not asked us to find it. So then we don't need to go to that extent. We could leave it like this. The question is to find the place, the x values, right? The question is to find the values, the first value. The particle first comes to instantaneous rest at point A, find the value of x at A, at the first place. So then basically you have to find the x value, the first x value. So when you come to instantaneous rest, what happens? At instantaneous rest, velocity is 0. So we will put velocity 0. 0.2 into v square is 0 square is 0. 14 over x minus, rather you can see that I only get one x value, right? 14, minus 2 comes here as plus 2 equals 14 over x. X comes to the other side as a multiplication. 2x equals 14, which gives me x equals 14 divided by 2 is 7. So this is the only x value you have. Okay, so this is the x value where it first comes to instantaneous rest. Is this clear?